CCE demo. I might have even started some things already. So what I'd say is that usually, personally, I like to create a separate VPC network for my Kubernetes clusters, CCE, whatever I'm doing. I like to create a VPC network for it. So here I've created one. You can see the VPC CCE, right? And I've also created a subnet, right? Also created a subnet called subnet K8S. You see it here, right? It's associated with this VPC. Alright, so now I'm going to go straight to CCE. I think I might already be deploying a cluster already, but okay. Okay, I'm creating a cluster, but let me just create another one. So we come to buy cluster, right? I think we were talking about this quite a while ago. CCE Turbo cluster. There's also autopilot cluster, right? But that's not in the material, so yeah, so we'll be creating a standard cluster. Right, I need to change this to pay-per-use. Cluster name prod. So prod is also production. So prod cluster, that's what I'll call it. Right, scroll down. Yes, this is your Kubernetes version, right? I think the latest Kubernetes version should be 1.33, 1.33, but 1.32 here is recommended. Right, then your cluster scale, the maximum number of nodes you can have in your cluster, right? You have to select this now. If once you select it, you cannot change it, right? You cannot like downgrade it. So we're just going to use 50, maximum of 50 nodes. Okay, so another thing here, we have master nodes, right? One thing I didn't mention yesterday is that you can have more than one master node, right? But you need at least one master node. You can have, for high availability, that's HA is high availability, you can have multiple master nodes. So you can have maybe like 3 master nodes or 2 master nodes. So if one node goes down, the other will continue its job. But we don't need high availability. This is still a lab environment, so we'll just use one master node. Alright, okay, so now this is where we select our network, VPC CCE, and then the subnet K8S, Kates, sorry, what did I say? Okay, node security group. It will create an automatic security group for the master node and worker nodes, because normally Kubernetes needs to communicate on some ports. One of those ports is 6443. I think that's for maybe the Kubernetes API server. So you need to make sure those ports traffic is allowed on those ports, right? So this will allow this to create an automatic group. Now another thing that we talked about yesterday was VPC network, right? Okay, you see that yesterday we talked about networking, right? This is your container network. Your node network could be at the VPC level, right? Your node network is your VPC and the subnet of your VPC. So for that will be subnet K8S. Now your container network, you could either decide to use the VPC, right? That would be better for high performance and lower latency, or you can create a tunnel network, right? So that will be based on the node network and then to create like a separate network. So here is where you select your CIDR block. We'll just leave it as is right now, right? Then you have your service network, right? This is your container CIDR block, this is your service CIDR block. Okay, so request forwarding. So Kubernetes uses can use multiple technologies to forward packets, right? Mostly used is IP tables, although there are other ones that are not even listed here, but IP tables and IPVS. If you want to read about that, you can check this or check other stuff. That's not really important for us to know right now. So let's go with IPv tables. You don't really need to configure anything in advanced settings. So next we go to add-ons, right? So now these are like extensions that you can add to your cluster. Node problem detector, log collector, and then Prometheus. This for monitoring. I think I mentioned that yesterday, right? And then this thing should scroll up now, right? You see these three here, right? These three are mandatory. Without them, your cluster cannot work, right? Without them, your cluster cannot work. That's your container network interface (CNI), your container storage interface (CSI), and then your core DNS, right? This is what I was telling you guys about yesterday, that Huawei Cloud have their own CNI. It's called Yangtze or whatever, and they have their own container storage interface (CSI) Everest. Okay, so far so good. I think all we just need to do is confirm, right? Agree, and then confirm. So since we're creating clusters, right, this is going to take some time to spin up. So okay. Oh yes, sorry, I think I had used that VPC to create my other cluster. So yes, I just even remembered. Cancel. Let me go to previous. I can't use that VPC network because I already have a cluster created there. So what I'll do is I'll use the default, the other VPC network. Sorry about that. So HCE, and then subnet HCE. Right, that's just to prevent conflicts with my other cluster. Right, I think this is good. Add-ons have been selected. Yes. I think I've agreed before. Yes, and then submit. So this might take a while to create the cluster and all that. So what happens when you create the cluster in Huawei Cloud? To create the cluster, but it's not create the nodes. You have to create the nodes after. So these are some of the stuff that you do: create the security group, create the network, and then create the cluster. Alright. So all these ones are done. This is now what is going on. So for now, we can just go back to cluster management. Okay, this is a cluster I have before. Yeah, you can see that it's almost very similar configurations. So what I'll do is that I'll pause this recording, and then when this is done, I will resume. Alright, so we see that this cluster is running. Now, one thing you should note is that when it creates the cluster, it doesn't put the nodes in the cluster. You can see here, no node in the cluster, create or accept nodes. So what I'll do is I'll go to create node. Okay, so just use pay-per-use. What's wrong with this thing? Okay. The availability zone, we'll just leave it to random. Now remember, I told you you can select your node type, whether you're using an ECS as a virtual machine, an ECS as a physical machine, or a BMS, right? So based on Kubernetes specification, let's just go with this. Alright, then you have your container engine. I don't think we talked about that yesterday. So there are two container engines: the OCI, which is the Open Container Initiative. The OCI standard is container D, but Docker can also function as a what is it called, container engine, but the OCI compliant one is container D, right? So you now have your operating system. I'll use Euler OS. You can name it prod cluster node. Okay, then you have your login mode. So we're going to use a password. You can also use a key pair, private key, public key, but I'm just going to use password. for simplicity. Okay. Alright, so then storage for the nodes, 150 gigs is fine for system disk, and 100 gigs is fine for a data disk. Okay, obviously we have the node settings, right? Then we have advanced settings. We don't really need to bother about that now. At the bottom here, you can decide how many nodes you want to create at once. Remember, we in the cluster configuration we selected 50 as the maximum number of nodes. So here you can create up to like 50 nodes, right? So me, I will just go with 3 nodes. Alright, so select confirm. Okay, so now I'll just have to tick that I've read this and then submit. So it's going to go ahead, and create those nodes. There you go. And it's going to create them as ECS. Maybe I can show you guys. Sorry. I'll show you in what's it called? In the ECS console, where it is. Where is ECS? It's lost the cloud server. Can you see that's okay, 2 of the nodes are already running. The last one is being created. It's being created using CCE image Euler OS this. Alright, so on the line, remember it is ECS that is running it. If it was BMS that I wanted, I would have selected BMS. So now you can see that all of them are in a running state. Let's come back to CCE. If I refresh this. Okay, so now it's not installing Kubernetes and the container runtime, that's container D, the container network interface, that's YAMT, and then the container storage interface, that's Everest. Right, so this one is running and is schedulable. Schedulable means that you can now deploy a pod on it, right? So these other 2 are still being installed. Okay. I don't know whether you guys saw it, that when we were here, okay, it says it's locked by CCE. That means you can't get into this node right now because CCE is performing operations on it. Okay. Okay, it's still installing these 2. I'll just give it some time. Okay, while it's doing that, let's see what other things we can explore. Okay. So workloads are, we talked about them yesterday. We talked about deployments, we talked about stateful sets, daemon sets. They're here, right? Deployments, stateful sets, daemon sets, jobs, cron jobs, and then pods. Okay, so that's that. And you have services as well, services and ingress, right? You can create a service or you can create an ingress here. Then for storage as well, right? If you need to create, can you see? You can create a PVC from here. This is PVCs. This is PVs. We didn't talk about storage classes, but yeah. But PVs and PVCs, you can create them from here. And you also have config maps, right? You can see that one has already been created. This is a certificate, right? That was created by CCE automatically. And you have your secrets as well, right? Okay. And policies. Okay, this is for HPA's horizontal pod autoscaler, as if you're increasing the number of pods. That's horizontal scaling. You have cron HPA, and then you have customized HPA. Let's see what else is here. App templates. Okay, remember I told you guys that Kubernetes also has a package manager, just like Debian family, that's Ubuntu, Debian have apt. So when you want to install a package, sudo apt install, right? So for Kubernetes also has a can call it a package manager, and that's Helm. I think we talked about that yesterday. But instead they are called charts, so like Helm charts, right? So yeah, in Kubernetes they are called charts, right? So this is where you would upload your charts if you are the Helm charts. Okay, then you have custom resources. They're also called CRDs, right? CRDs, custom resource definition, if you want to create those, but all those were not talked about in the material, so those are like a bit advanced concepts. Then you also have namespaces, right, for segmentation, right? Whenever you create a Kubernetes cluster, you would have the default namespace and then your kube system namespace. Your kube system namespace is what stores your master node, your master node resources, right? They're all usually in your kube namespace. So stuff like your controller manager, your etcd, your what else? There's one more. Controller manager, kube scheduler. Yes, they're all in the kube system namespace. Okay. I think all our nodes should be running now. Exactly. All our nodes are running. Okay, all our nodes are running, so that means we can check them out. Okay, so the first thing we'll do now is let's deploy a workload. Let's create a deployment. You can create it from YAML or YAML. Let's call it YAML. So YAML is basically a language that you use to define your Kubernetes resources. You can use it to define other resources too. It's just like JSON, JavaScript object notation, but in Kubernetes we use YAML. So basically it's just a let me see if I can show you guys one. YAML Kubernetes, right? It's basically what you use to hey Jesus, I don't understand Chinese, so I'm guessing they are talking about bicycles. So that's what you use for your resource definitions, right? This capture national. Okay. Ha, no, I failed it. I'm going to guess these are zebra crossings. What else? Okay, one more. This one here. Call me Zang from now on. What do you mean? Okay. Is there a way to change this thing? Okay. Okay. Let me just show you guys from the Kubernetes documentation. Let me see. Okay, this is one. This is a deployment. You know what? Let's use this deployment in CCE, right? So this is a deployment. You have the metadata, which is the name of the deployment. Then you have the specifications, blah blah blah. So yeah, all these are. So now these are the containers within the pod, right? We're just getting Nginx. So let's do this. Instead of doing clickabout, let's use YAML to deploy it. That's one good thing. Although this will not be really applicable to you guys, you can always go to the documentation and pick up YAML files and use to. So here we have our YAML file. I'm just going to paste it. Right. Then we're going to submit. Hopefully this goes well. Okay, you can see it has already picked the image name, Nginx, and it's processing the deployment. Right. So let's see. Okay, and now our deployment is already running. right? Our deployment is running. We have two pods. That are running. This is their IP address, and then this is the node that they are running on. Okay, this is the node that we're running on. Let's go back to ECS and we check. I don't know why it didn't give us the name. It just gave us the IP address. So you can see that one pod is running on dot 13 and one is running on dot 130. So that means that one is running on this node and then the other pod is running on this node. Alright, okay, so yeah, these are pods. If you check our containers, we only have one container. We have an Nginx container, right? We didn't configure any auto scaling, right? So yeah, that's basically it. We can come back, right? Okay, if we come to services, we can create a service for our pod. Let me see if I can get a YAML file. Services. Okay, so I'll use that to see if I can deploy a service for our Nginx. Selector. Let me check the selector we used for the Nginx pod before. So that will just map it. The selector is app and Nginx. Okay. So if we're going to change this YAML file, come here. Okay. Let me see if there's another one. We can still use this one. I think that's the one. Okay. This is perfect. This one has some custom definitions. I don't use any select. So another thing is that there are different types of services, although I'm not sure that was really considered in the material. You know what, let's just use this service. So okay, this selector is using the name selector. Let me see, for this is going to be app. Okay, so I'll just modify that. Let's create from YAML, or you know what, let's create from the console, because that's the whole point of this, right? Okay, so when you're creating, you can create whether you're using a cluster IP. That would mean that the service is going to use the IP address from your cluster. You can create on a node port. So what it will do is that all your services will have the same IP address. It's just that they'll point to different ports, right? And I think the port ranges from 30,000 to 32,737. Okay. Then you have load balancer if you need to distribute traffic, right? Then you also have DNAT. Let me see if we come here, I can talk about the various services. Where does it talk about? It doesn't talk about them here now. Okay, let me search node ports. I just want to see if I can quickly get. Okay, yes, these are the service types. Right, so you have cluster IP, exposes the service on a cluster internal IP. So that's the IP address from your cluster, which from these hours would be which would be the VPC, right? Which would be the IP address from the VPC. Okay, like we said, this would make the service only reachable from within the cluster. right? And then if you want to expose it to the public, you can use ingress or gateway. Okay, so because the material, a lot of changes have been made to Kubernetes since the material was created. There is now a new way to expose your services to the internet using what is called Gateway API. But since it's not covered in the material for the exam, I will leave that. So you have ingress or gateway. The node port exposes the service using the node's IP address. So back here, we have this. Where is it? We have this IP address. So what would happen is that if we wanted to expose, let me go back to where those ports are. Refresh. Okay, if we wanted to expose, where's our deployment workloads? Right, Nginx deployment. Okay, so if we wanted to expose this particular deployment, right, this is the node IP address, right? So what is to do to expose it using this IP address and then a port number. So something like ports. I said that the range of the ports is from 30,000 to 32,000. I don't know why they didn't specify it here. So to use the IP address of that node, so that means that it's use this IP address, right? What's this? Okay, to use this IP address and then a port, a specific port to point to that service. So I don't know if you guys understand. So let me just use an example. So now when you visit a website in your browser, right, the default port for HTTP is port 80. When you go to your browser knows that it's looking for it's loading the site from port 80, right? You can have multiple websites deployed to the same server on different ports. You can have one deployed on port 80 and have another one deployed on port 8080. It's also used for what's it called? It's also used for HTTP as well. Alright. So yeah. Then you also have load balancer. This will allow you to connect to your external load balancer. So for that, this will allow you to connect to your ELB. And we have external name. This is not in the material, but it's just basically like a form of DNS mapping. Alright, so this is cluster IP, node port, exactly. This is what I was looking for. Right, so your node port goes from 32,000 to 32,000, from 30,000 to 32,767. So this is the port range. So what will happen is that if you deploy a service, it will choose a port at random between this port, and that's what it will deploy your service to on that node, this particular port. Okay, so where is the place we're selecting? So we are going to go with, we're going to create two. We're going to, let me just call this cluster IP SVC for Nginx. Right? Selector. I think when we defined that other one, we used, this is the selector here. So the selector is app and Nginx, so that it would select, that's for it to be able to know which pod we're talking about. Come in here. So the key is app. This is key value pair that we are talking about yesterday. So this is app, and then this we're looking for Nginx. We add that. Right, so the port, the container port, I don't know whether it exposes it. Okay, container port is port 80. So we select that. Container port and service port, just use the same one. Right? And then we're using cluster IP, so okay. So there to create a service, right? It's a cluster IP service. If you remember when we're creating the container network, the container network had this what's it called? The container network subnet had this particular format, 10.247 dot something. I can't actually remember. Right? We can also create a node port service. So I'll show you. So we'll call this node port, then we'll call it SVC. SVC stands for service, and then nginx. Right? The key, we're going to use app, and then nginx. Right? You can add multiple selectors. So the same thing, the container ports and the service port are the same ports, 8080. Then once you create OK, you see that, can you see? What is the same cluster? Why? You see, this is the port that is pointing to port 31. This is the port it chose, right? 31539. 31539. Okay. Yeah. So that's services. Yeah, that's two services. So yeah, I think that's practically what I wanted to show you guys. You can also decide to use the CLI. So if you're like me and you like entering commands by yourself, okay, my lab environment won't allow me to do that, sorry. So yeah, you can also use the CLI for that. Okay, yes, this is what I was showing you guys. For the cluster IP, it picked a IP address from here, right? And this container cluster network that we created, 10.247.0.0.16. So that's practically it. Yeah, then you have your monitoring. You can also create secrets. Let's create a secret. Okay, so maybe you want to create your secret, maybe your Docker login. I can spell Docker login, right? Namespace. Okay, I think maybe we should check that too. You can have a description for it. Credentials for Docker. Secret type, it's usually opaque, right? It's usually opaque. So now you have the key and then you have the value pair. So now you add the key. So let's say my Docker login is vicdev@gmail.com. And let's say my Docker password is HUAWEI@1234. You see, it automatically selects the base 64 encoding. Once you click OK. Really? Okay, let's just say vicdev then. So, and then click OK. And you see that you have your Docker login secret. And you have the value if you need to see it. Okay. Is there anything I wanted? Okay, namespaces. So namespaces are also for the segmentation. I think we talked about that when we were talking about introduction to containers and stuff. Namespaces are also, they're used for segmentation. So you have your default namespace. This is where all your pods will be in. You have your kube system, right? This is where all your master node pods are going to be. I don't know whether we'll be able to even see. We'll be able to see the pods from the master node here. No, it's not showing. I think it's just showing from the default namespace. So yeah, that's practically what I wanted to show you guys. Yeah, I think that's what I wanted to show you guys. Great. that's practically the basics of CCE, right? That's practically the basics of CCE. You can do so much more. Definitely, it's something that you might want to come around, play around with. So yeah, okay. I don't think there's anything else. Storage. Okay, let's take a look at storage. Okay, so now let's take a look at storage. First of all, we'd create a persistent volume PV. You can always create from YAML, which would normally that would be my choice. So you can just search for PVs in the documentation, and that's persistent volume. One thing I love about the Kubernetes documentation is that there's always examples of YAML files for you to use. Okay, see, this is I think this should be a pod. Yes, this is a pod definition. What is this? Yeah, this is a persistent volume. It's a persistent volume. Okay, but since we just use the click around wizard in HUAWEI CLOUD. So exactly, now you can see that you can select your volume type, your EVS, your OBS, or your SFS token, or your DSS. I think this should be distributed storage, right? So if you have your EVS, you can select it. Okay, these are the EVSs that I created. If not, we're going to have to create one ourselves. Okay, you know what? Let's do that. Let's do that. So let's go to EVS and create one. EVS. Okay, so you can see that these are some of the EVS that was automatically created from my what's it called, from the cluster I have. Some are data disks, some are system disks, right? That's why we have 6. We have 3 nodes. I have 3 nodes, each one with a system disk and a data disk. So that's why we have 6 volumes. And now we're going to create another volume. Scroll up. So let's go by disk. Allow it to select paper use. We'll just make it. I will make it 10 gigs. We don't need much. Okay, we're not doing backup. Now we need disk name. I'm going to call it volume PV Kates. Sorry. I'm just going to create one, right? And submit. Alright. So now I have my disk, and you can see that right now its state is available, it's not in use. So now we're going to go back to CCE and we're going to select it. Okay, we'll select this. Oh, we need SCI disk, so unfortunately I'll have to go back and create another one. Okay, what is this? Okay, let me delete this one. So it says only SCSI. It's also called SCSI. SCSI is also called SCSI, but only SCSI disks are supported, so we'll have to delete that and create another one. Let's go up. By disk. Okay, so we are now attaching to a server now. Later, 10 gigs AP Singapore. Okay, let's mount it to the AZ where our nodes are located, right? So that's AZ3. You can see that I have 3 servers in this AZ. So they said we need to be a SCSI. We're not doing backup, and then we're going to call it volume PV gates only creating one, right? You can select this type, whether general purpose, high IO, ultra high IO, but I'll just leave it as general purpose. So click next, click submit. Now you see, normally if you're doing this in a Kubernetes cluster that is not CCE, you're doing this by yourself, all this clicking around is not what you'll be doing. You'll be using command lines, which is why they say that that's one of the advantages of CCE. It provides simplification, right? Just clicking around the console, you can do all these things. Okay, so let's go back to our CCE. Let's refresh. You can see that this is now available. So we'll select it and click OK. So we need to call it a PV. So let's call it, let's say what this is for the Nginx that we deployed. So then you have the access mode. Access mode is usually read-write once. I don't think they talked about it in the material again, so let's not go into that. Okay, so you can create. Okay, you can see that the PV has been created. Now you see that the status says bindable. That means it has not been claimed. It has not been attached to a pod. Right, so if we attach it to a pod, it should show bound. It should show bound. Okay, so now we'll create a PVC. Right, so let's go to create PVC. EVC. So we're going to call this PVC Nginx. We're using the default namespace. So for provisioning, you can leave it as dynamic provisioning. Okay, the AZ, or using the AZ1 because that's where our servers are. Capacity, we're going to, okay, I think 10 is the lowest that you can create. Okay, so what else? Minimal paper use, key, this, and that. Yes. Resource tag. Let's use the app and the Nginx that we had before. We don't need to encrypt it. You can add that. Okay, so now we have our PV created. PVC, sorry. This is close. Have our PVC created. So now it's waiting for a pod to bind to it. So that's what we will do. We will go to our Nginx pod. Okay, this is PVC Nginx, right? Let me duplicate this tab so that we can go back and try to bind this to our